Hi friends, today in this video I'll talk about the function of a gate in an injection mold, or while designing an injection mold, what what are the different points to be kept in mind by the designer to design a gate. So as in my previous videos already told, uh, gate is a part of the feed system. The feed system in an injection mold consists with a sprue, runner, subrunner, gate, then the material will flow inside the cavity. So gate is located in between the runner and the impression, or that is your cavity. That's why friends, the gate is an entrance before the hot melt will enter the cavity and it will fill the cavity. So the entrance through which molten plastic material flows into the impression or flows into the cavity, that is called a gate. And gate design will be very important because it will be a small hole, small orifice through which the material will enter inside the cavity. The purpose of the gate is also to increase the pressure before the material will enter the cavity because the cross-sectional area of the runner is little larger compared to the cross-sectional area of a gate. For that reason, when the melt will flow through the gate and supposed to enter your cavity, the pressure will increase. And it is generally done purposefully because if the pressure will increase, then with a high pressure, the material will enter the cavity. That's why the location of the gate, where it will be, what should be the type of gate, what should be the size of gate, will be very important when you are going to design the feed system for an injection mold. So, a definition, an injection molding gate, it is a critical component in your mold design which serves as the point of entry for the molten hot plastic material into the cavity. Let's say the gate, that will control the flow of material from the runner system to the actual part geometry, imparting the overall quality, the appearance, and the performance of your molded part. If the design of gate is not proper, then on that case also what will happen, we will get different type of problems, like sometimes this distortion problem will be there, warpage problem will be there, ejection sometime will be a problem, then weld line formation, all these things. And the location of the gate, the size of the gate, shape of the gate, all these things, that will be decided by considering many factors. So some of those factors are the material, actually. The plastic material what you are going to use to make the product, that sometime will decide what type of gate you have to use. So the molding material as well as the geometry, the appearance of the product, that will be another thing, another point to be kept in mind, because sometimes you will decide a gate and the impression of the gate after ejection, that will be on the outer surface of the product. So sometimes the customers they might have actually for that product, actually they might have some restriction that the impression should not be visible to public. So in that case, you have to design or you have to choose the type of gate different. So mold material, part geometry, then what type of the problem issues you are getting actually in injection molding. Based on those many factors, you have to decide what type of gate you are going to use. Okay. So it is, as I told already, it is a small orifice through which the molten material will enter the cavity. That is the function of a gate. And always what the designers they used to do generally, they will keep the location of the gate or the thickest section of the part. That means suppose the part thickness is uniform throughout, then no issue. You can put it at the center of gravity or at the center of the gate, so the center of the product, so that actually the flow will be uniform. So the gate balancing is runner balancing. These are actually some of the other issues to be taken care. But today I'll talk about only about the different type of gates and some of the key points you have to keep in mind while designing a gate. So some of the key points are as it is a critical component in the mold design. So by the choosing of the correct gate, choosing the correct type of gate is very important. The function of a gate, is already told, is very easy actually, because its job is only to uh, make the material to enter your cavity, but choosing the wrong type of gate will cause a lot of problems during the processing, and finally actually your product will be rejected. So proper gate location, proper selection of the gate placement are crucial for achieving uniform filling of the mold, minimizing the defects and optimizing the production rate and quality of the plastic components. So while choosing a gate or the location of the gate for a molded part, there are few important factors to consider. The first is how the mold will be designed and where the gate will be located. Like we are using nowadays many softwares actually, so that we can do actually the different iteration by locating the gate at different locations. So to check it actually the optimized location for the gate. So by using software itself actually we can do it. And the part orientation in the mold, the surface location. Uh, so these are some of the things actually has to be kept in mind. Further, the design considerations are material selection, the part volume or size, and production functionality. These are some of the other factors has to be kept in mind. Some plastics, because as already told you actually the type of plastic material sometime will decide actually what type of gate you have to use. So some plastic materials are there, they are very much sensitive to overheating, and the materials which are sensitive to overheating, that type of situation is called actually shear heating. So attempting to fill a large plastic part with very small gate will create sometime actually very excess amount of shear heating. So if the shear heating, that means the temperature will go up, and if there is a situation of excess amount of shear heating, that could lead to actually degradation of the plastic inside the mold, and sometimes the gate could freeze off before your cavity is totally entirely filled. Actually, it is required. It is required to freeze the gate, but once actually the cavity is filled completely, then only freeze it, so that the flow from the nozzle side will be stopped. But suppose the cavity is not filled and the gate is actually freezed, then there will be a situation of short. That means you won't get a entire component. That means out of your 100% of that component, only some 60%, 70% might have filled, remaining 30, 40% left out empty. So that again, actually the product will be rejected. The other things to keep in mind, the gate freeze is an important aspect of the injection molding process. It is required. But as I told you, it should not freeze off actually before the cavity is filled. So gates need to be large enough to fill out the cavity properly, but it should be small enough also to seal the cavity, and it should freeze once the material is filled inside the cavity. The gate freeze should occur when the cavity is completely packed out and ready to start the cooling process, because after that actually you have to give time for cooling, and then only actually the component will be ejected. So since the gate is small, it should cool off relatively quickly compared to the molded part or the feed system. Gate freeze allows the part to become isolated from the feed system. Now we'll come for actually what are the, because that is the main agenda for this video, what are the different type of gates in injection mold. So basically the gates are classified into two groups. Gates are classified. Gate, as I told you, it is a part of actually your feed system. Like actually in the diagram, there is a screw, there is a runner, there is cold slug well, sub runner, then only gate, and that is the entrance of your cavity. So what are the different type of gates? Basically, so gates can be classified as two groups. One is called actually manually trimmed gate. In case of manually trimmed gate, actually you need a secondary operation to trim the gate, and the other one is automatically trimmed gate. So there you don't need a secondary operation. So gates are basically we can classify it into two. One is manually trimmed gate, the other one is automatically trimmed gate. Now, what are the different type of gates? As I told you, there are so many type of gates, and if you have a complete knowledge of all the type of gates, for which type of gate is suitable for which type of material, or which type of gate is suitable for which type of geometry of the part, then only you can take a correct decision, uh, and you won't get actually in difficulty of filling the material inside the cavity, and you will get good product. That means the product will not be rejected. So the manually trimmed gates are I wrote a few of the names only. One is called sprue gate. This sprue gate is used only for single cavity. When you are going to design a mold and it is a single cavity mold, then on that case actually you have to go only, the option is actually to go for sprue gate. So one is sprue gate. This one comes under the category of manually trimmed gate. That means once your cycle is over, then actually you have to detach your feed system from your original part. So you have to trim it manually. One is a sprue gate, another is rectangular gate or edge gate. Third one is overlap gate. Next is fan gate, tab gate, diaphragm gate, and film gate. So these are few of the names which comes under the category of actually manually trimmed gate. So what are those gates? One is sprue gate, rectangular gate, overlap gate, fan gate, tab gate, diaphragm gate, and film gate. So as I told, they are classified into two groups. One is manually trimmed gate, the other one is automatically trimmed gate. So the automatically trimmed gates are these are the types. One is pin gate. Pin gate comes under the category of automatically trimmed gate. Many times actually in case of 3-plate mold, the mold designers, they used to recommend actually to go for actually pin gate. The another one is submarine gate. In case of submarine gate, because the melt will flow into the cavity below the parting surface, below the parting line. So on that case, while opening your mold, that time itself actually, while ejecting, that time itself actually the gate will be trimmed automatically. So you don't want to do anything manually. The third one is hot runner gate, and another is called actually valve gate. So dear friends, these gates can be classified into two groups. One is manually trimmed